Welcome to the Explainer. All right, let's get right into it. We're about to go on a trip. 13.8 billion years back in time to try and answer one of the oldest questions there is. Yep, today we are tackling the history of everything, the Big Bang. I mean, it really is the ultimate origin story, right? For most of human history, a question this big, well, it belonged to priests and philosophers. But in just the last century, scientists, astronomers, they've actually uncovered a real scientific answer. And it's written in the stars themselves.
And you know what's wild? The biggest clue to where we all came from is hiding in plain sight. It's literally encoded in the light from distant galaxies. And it tells us a story of a universe that isn't just sitting still. Oh no, it's in constant dramatic motion.
So, let's talk about that. An observation back in the 1920s just completely flipped everything we thought we knew about the cosmos on its head. It was the very first piece of evidence that pointed to a universe that was dynamic, evolving, and, crucially, had a definite beginning.
So here's the key observation. It's actually pretty simple. The farther away a galaxy is, the faster it's moving away from us. A great way to picture this is to think of dots drawn on a balloon. As you blow up the balloon, every dot moves away from every other dot. It's not that we're at the center of some grand explosion. No, it's that the very fabric of space itself is stretching, and it's carrying all the galaxies along for the ride. And this, right here, corrects a huge misunderstanding. The Big Bang wasn't an explosion in space, like a firecracker going off in a dark room. It was the expansion of space. The space itself was expanding. Every single point in our universe today, it was all once the exact same point. The beginning didn't happen at a single spot. It happened everywhere, all at once.
Okay, so if we take this idea and run with it, if we rewind this cosmic movie, what do we see? We see a universe that was once unbelievably small, incredibly hot, and super, super dense. I mean, an inferno like that couldn't just disappear without a trace, right? It had to have left something behind, some kind of cosmic fingerprint.
And that's the beautiful thing about this theory. It didn't just explain the expansion we were seeing. It made these really bold, really specific, testable predictions. It basically said, hey, if this is true, here's what you should find if you go look for the after effects of that ancient, super hot state. And it's these predictions that took the idea from just a hypothesis and turned it into a pillar of modern science.
So, scientists went looking for two very specific things. First, a faint leftover glow from the baby universe. And second, a very particular recipe of the lightest chemical elements cooked up in just the first few minutes. And what's so incredible is they found both.
Okay, so the first fingerprint. This is the cosmic microwave background, or the CMB for short. And it was actually discovered by accident back in 1965 as this persistent static, this hum in a radio antenna. Turns out, it's the oldest light in the universe. It's basically a snapshot from about 380,000 years after the beginning, the moment the universe finally cooled down enough for light to travel freely, the moment it became transparent.
Now, get this. This ancient light, it was once hotter than the surface of a star. But after 13.8 billion years of being stretched out by the expansion of the universe, it has cooled way, way down to just 2.725 Kelvin. To put that in perspective, that's about minus 270 degrees Celsius, just a tiny whisper of heat above absolute zero, the coldest anything can possibly be. All right, on to the second fingerprint, the primordial recipe. The theory also predicted the exact chemical makeup of the brand new universe. In the blazing furnace of the first 3 minutes, a period we call Big Bang nucleosynthesis, protons and neutrons were smashing together, fusing to form the very first atomic nuclei.
And the results? Honestly, they're stunning. When astronomers look out and measure the makeup of the most ancient gas clouds they can find, they see the exact recipe the theory predicted. About 75% hydrogen, 25% helium, and just a tiny, tiny dash of other light elements. It's a perfect match. So, with this mountain of evidence in our corner, we can now rewind the clock with a lot of confidence. We can actually tell the story of the universe, starting from its very first, absolutely mind-boggling moments. So here's how the story goes. In the first fraction of a second, a process we call inflation stretched the universe out exponentially. I mean, poof. Then, within just 3 minutes, the basic building blocks of matter, hydrogen and helium, were created. For the next 380,000 years, the universe was just this opaque, glowing fog. Then, suddenly, light broke free. That's the CMB being released. After that came the cosmic dark ages, which lasted for hundreds of millions of years, until gravity finally started to win out, pulling gas together to light up the very first stars.
Now, this is a really crucial point to understand. The Big Bang Theory is a model of evolution, not creation. It explains with incredible precision how the universe evolved from that initial hot, dense state. But it doesn't tell us what caused that state in the first place, or what, if anything, came before time zero. And that remains one of the absolute greatest mysteries in all of physics.
But hold on, because the story is far from over. In fact, everything we've been talking about so far, all the stars, galaxies, planets, you, me, all the gas, everything made of atoms, well, it turns out that's only a tiny, almost insignificant fraction of the entire cosmos.
Yeah, this is the universe we actually live in today. And it is overwhelmingly dominated by two super mysterious things we can't see, we can't touch, and frankly, we don't really understand: dark matter and dark energy. All the stuff we know and love. It's less than 5% of the total cosmic budget. Crazy, right?
So what are these things? Well, dark matter seems to provide the extra gravitational glue needed to hold galaxies together and keep them from just flying apart. And dark energy? That's something else entirely. It acts like a repulsive force, a property of space itself that's actually causing the expansion of the universe to accelerate, to speed up.
And this acceleration leads to a really fascinating modern mystery. Think of it this way. Say you want to know a car's current speed. One way is to look at where it started and calculate its speed based on its known acceleration. That's kind of like using the CMB to measure the expansion. The other way is to just, point a radar gun at it right now. That's like using nearby exploding stars to measure it. The problem is, cosmologists do both of these things, and they get two slightly different answers. We call this the Hubble tension, and it's a huge clue that maybe, just maybe, our understanding of the universe is still missing a piece.
So, given everything we know, and maybe more importantly, everything we don't know, what does the future actually hold for our universe? I mean, where's all this headed? Well, while the Big Bang is absolutely our best, most supported model, it's not the only idea out there. The old steady-state theory, the idea the universe was just eternal and unchanging, that was pretty much ruled out when we discovered the CMB. But today, some physicists are exploring even wilder ideas, like a cyclic universe, where a Big Bang wasn't the beginning, but just one event in an endless cycle of expansion and collapse.
But based on the current evidence, it looks like, thanks to that mysterious push of dark energy, the expansion isn't slowing down. Nope, it's speeding up. And that points to a pretty bleak future. A big freeze or heat death. A future where galaxies just get farther and farther apart until they're completely isolated. The stars will all eventually burn out, leaving behind a cold, dark, and empty universe, billions and trillions of years from now.
And that kind of brings us full circle right back to where we began, at the absolute boundary of our knowledge. Our science, our physics, can describe the universe from the very first instant onward with just stunning success. But that very first moment, and that nagging question of what came before, well, that's where physics ends and speculation begins, and it leaves us all to wonder about the true origin